Hello everyone. This video is for my geometry students. We're getting close to having an assessment on working through writing equations of lines that are parallel and perpendicular to a given line through a given point, and some other kind of algebra review, kind of a check-in for you guys. So I wanted to just make this video so you had kind of one more example as a reference, so you can study and do a good job. All right, let's try this. All right, this first question, the first thing I'm seeing is that I want the equation and I want the line that is parallel. Okay, so that word parallel right there means right away that we are going to be working with the same slope. So when we think about writing the equation of the line, it's nice to know the slope. Okay, it's nice to know the y-intercept. If we have that, that can be helpful in writing our equation. But we can also use a point. And these three pieces of information could help us to write an equation in either slope-intercept form or point-slope form, depending on what information we have and how you want to proceed. Okay? So you have these different forms that we can go with. Remembering that if you have parallel lines, you are going to have the same slope. Okay, so the same slope is going to happen if two lines are parallel on the coordinate plane. They'll never intersect. Okay, so let's see what happens here. Y equals negative 2x plus 7. 1, 2, 3, 4, 5, 6. Here's 7. And negative 2 means we're kind of looking at something like this. And if it helps you guys at any point through this process to graph rather than just going straight to the equation, please make use of graph paper and tools if you want to make sense of that problem. So we have a slope here of negative 2. And because we have the same slope for a parallel line, the slope for our equation is also going to be a negative 2. Okay? And then we're given a point. And that point is the point negative 3, negative 5. Now, some of you, especially if you're really into just working with equations, some of you might want to just take this piece of information and this piece of information and plug it into point-slope form, which is totally fine. We can totally do that. In fact, let's try it right now. We're going to do y minus your y-coordinate, which is negative 5. So that's going to be a plus 5 is equal to negative 2 times x minus a negative 3. When we subtract our negative 3, that's going to be positive. And that's it. You've written an equation for the line. Some of you, okay, and that was the point that we used right here, this negative 3, negative 5 point. Some of you might like to actually graph that point negative 3, negative 5. So let's try it. 1, 2, 3, negative 3, 1, 2, 3, 4, negative 5. And use our slope of negative 2 to find your y-intercept. If that's how you would like to do a problem like this, then go for it, right? It looks to be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Looks to be a negative 11 for our y-intercept. So one of the things we could do is we could actually write our equation for the parallel line with the slope and y-intercept of y is equal to negative 2x minus 11. Now I'm kind of curious, okay? Kind of curious if these actually are the same, okay? Well, remember some of the algebra you could do to check this would be to distribute your negative 2 in point-slope form, making this negative 2x minus 6, and then as you subtract 5 from both sides, hey, look at that. we get y is equal to negative 2x minus 11. So yes, in fact, you can get to the equation in both ways. All right, so we covered a lot in just that one example. The biggest change you're going to see in the next example is that we're working with a perpendicular line instead of a parallel line. And really the only thing that changes is how we find our slope. So we're still going to be using these same nice equations for slope, intercept, and point slope form. We're just going to be applying them to a situation where we have lines perpendicular. So here's my original equation, is y is equal to 2/5 x minus 1. And again, 1, 2, 1, 2, 3, 4, 5. You can draw your line. If you would like to do that, do it. Make it happen. It's perfectly fine to do that. It's important that you be able to identify the slope of that original line and then to find the negative reciprocal. So your new slope, right, the new slope of the line perpendicular is actually going to be a negative 5/2. Okay, so we have our slope, we have this point, negative 1, 4, negative 1, 1, 2, 3, 4. Okay, and I can just use this information over here to write my equation. Watch how I do that. I'm just going to do y minus my y-coordinate of 4 is equal to my new slope, negative 5/2, times x minus my x-coordinate of a negative 1, so it's going to be minus a negative. That's going to be plus 1, just like that. And of course, if I distribute and then add 4, it looks like I'm going to get a y-intercept that is probably has a fraction in it, and that's okay. All right, we can have something that has a fraction in it. No worries there. Let's see if the drawing this line makes it look perpendicular. Let's see, negative 5/2 from this point. 1, 2, 3, 4, down 5, right 2. And here is my line that is perpendicular to that purple line. And in fact, it does look pretty good there. And we know they're perpendicular because of their slope. So again, the algebra on this piece, if we continue to distribute your 5/2, which is like 2.5, so we'll just change it for the sake of working through this quickly, and a minus 2.5. And if we add 4 plus 4, is that going to be a positive 1.5? Negative 2.5x plus 1.5. Let's go and check and see if that seems to be about right. Oh yeah, look, right there. That's where it's crossing the y-axis. Very good. So you can leave your equation like this, or keep it in point slope form. Either way works. All right, last example here, guys, for this video today is one more example of graphing a system of inequalities. And so we're going to start by remembering that if you have less than equal to or greater than equal to, we are going to have a solid line for our graph. And if we have strictly less than or strictly greater than, we're going to have a dashed line for our graph. Okay, so let's go check this out and see what we got. So y is greater than 2x minus 4. I'm going to recognize that that 2x minus 4 part means I have 1, 2, 3, negative 4, a slope of 2. So it looks like it's going kind of up like this. It is strictly greater than, so I'm going to have a dashed line that separates this coordinate plane into two parts. Remember that a good way to decide which half to shade is by testing a point. So we're going to test the point 0, 0. Here we go. I'm going to do it right down here. 0 is greater than 2 times 0 minus 4. Is 0 greater than negative 4? If you can say yes, 0 is greater than negative 4, then we want to shade on the side that includes that point 0, 0 that we tried. Okay, so we're shading everything over here, just like this. And then I'm going to switch up colors. What should we pick? Let's pick this kind of pink color right here. Okay, and I'm going to graph y is less than or equal to 1/3 x plus 1. So I'll go to my 1. I'm going to have a slope of up 1 over 1, 2, 3. 1/3. It also has an equal sign, so I know I'm going to make a solid line, solid line, solid line, solid line, right through those points. Solid, 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 solid. Okay. And here's the point 0, 0, so I'm going to go ahead and test 0, 0 and see which way we have to shade. So let's try it. Is 0 less than or equal to 1/3 times 0 plus 1? Well, we know anything times 0 is just going to be 0, so is 0 less than or equal to 1? Is 0 less than or equal to 1? So then we say, yeah, it is. Okay, so this point 0, 0 is included in our shaded region, so we're going to shade everything under that side that includes the point 0, 0. And then really the solution is anything that is called an intersecting shaded region. And I kind of like to use this highlighter. Maybe I'll just use yellow this time. And I'm going to highlight everywhere I see a green and red overlapping. So this entire section where I see green and red overlapping is actually the solution to our system. All right, guys, I hope you found this video helpful. You can refer back to it if you need any help with graphing parallel and perpendicular lines or graphing inequalities, systems of inequalities. Okay, have an awesome day, guys. Keep working hard.